This video is intended to cover some of the reactions of alcohols, and it's working through a past paper from June 2009 from the OCR F322 Specification. It starts off, a picture of 4 different alcohols, and the first one focuses on the one they call A, ethanol. I'll say it's a very useful alcohol. They don't want the uses, however. What they want is the 2 main methods used in industrial production of ethanol, with an equation for each. Again, reading the whole question will give you 4 marks, 2 methods, 1 mark for each of the methods and 1 mark for the equations. Most of the mistakes, or not mistakes, but most of the drop marks come from people writing down fermentation and skipping on. They want you to write more than just fermentation. Fermentation of sugar is the key thing that you had to put in here. You could have said reaction of sugars catalyzed by yeast, but fermentation is the phrase they want, and of sugar. So there are many multiples that you can go with, but make life easy for yourself. C6H12O6, and you're going to make, well, ethanol, you're already told that up there, so it's C2H5OH, and you're going to get some carbon dioxide. 2 and 1 is 3, we need 6, so we double everything up. So that's your first one, you must learn that. Now, there's another method that can be used. This is from sugars. There's one where you can take ethene and you can react it with steam. The advantage of this is that it is 100% in the atom economy. The disadvantage is, of course, a lot of the ethene is sourced from crude oil. So C2H4 plus H2O goes to C2H5OH. No requirement for state symbols given there, so I'm not worrying about putting in the G for the steam. Okay, so that's 1 mark for each description, 1 mark for each equation. You could also have called this the hydration of ethene. Right, part B. Student heated each alcohol with acidified potassium dichromate. This is something that you need to recognise as an oxidizing agent. This is one you must learn. They tell you it here, but it's one you have to know about. Goes from orange to green for A, B and C. Well, if we look up at this, on the carbon that the OH is bonded to, there's only one other carbon, so that's primary. This one, 1, 2, secondary, only 1, primary, but here, 1, 2, 3, so that one's tertiary. You need a hydrogen bonded directly to the carbon that the OH is bonded to if you want to oxidize it. So for D, there would be no further oxidation, whereas for A, B and C, you can oxidize all of them. Okay, it then picks specifically B. So again, looking up at this, we know that that one is secondary. It's only going to do 1 oxidation. What you've got to do then, let's have a look. 2 marks. Identify the organic product and write a balanced equation. And then use O in square brackets to represent the oxidizing agent. Right, well I've summarized, or started off to save some time, and I've put the 2 methyl groups together to make that easy, plus O. But rather than doing my equation with this structural formula, let's go back up to the displayed formula. We're going to take away the hydrogen and make another bond to oxygen. And so therefore, that is what you're going to get here. That is propanone. So if we put this in here to our equation, the 2 methyl groups and the CO, we've removed 2 hydrogens, and we've removed them in an oxidizing environment, so we get H2O as the byproduct. That is one that people will miss out. That's one you've got to know about. First oxidation of either a secondary or a primary alcohol, you will get water as a byproduct. Right, keeping going. This time, the organic product obtained from C was analysed by infrared spectroscopy. Right. C is a primary alcohol. It is in fact 1, 2, 3 propanol. So you are either going to get propanal or propanoic acid. Make sure that you don't overcomplicate things for yourself. Think about, well, what are my only possibilities? You know it's either one of these two chemicals. Now use the infrared spectrum, which is used to identify functional groups. We have here this sharp peak in the region of 1700. That's your carbonyl. Now, looking here, there are 3 marks they want you to identify and the reasoning. By reasoning, they mean refer to the spectrum. So what you put in is a peak at, now I'm going to say that's 1720 centimeters to the minus 1, is this. Link the peak to the bond. A range of 1640 to 1750 was allowed. It's about as faint as you can get, but there is a really broad peak there. So get in fact I'm going to put a very broad peak, and I think this is starting at about 2500 to about 3300. The range given in the mark scheme, oh, it was exactly that. Hey, well done OCR. And what that tells you is the OH from a carboxylic acid. You will get a data sheet, and if it was an alcohol, it would be a much narrower range. But because we know we're either looking for an aldehyde or a carboxylic acid, I'm not worried about telling if this is the OH from an alcohol or a carboxylic acid. There's only one possibility for me. And so therefore, organic product, propanoic acid. You could have put the formula if you had wanted. If you had a bit of a panic about naming it, it would just be CH3, CH2, COOH. Remember, you will lose those 2 hydrogens. Right, to save some of that awkward flipping, I have written the formula of alcohol D in here. It says D was heated with ethanoic acid in the presence of an acid catalyst, and organic product E was formed with a fruity smell. Oh, hang on, I'm going to jump here. Name the functional group. Ester. Look out for that fruity smell. They love that. Again, you know, you should also spot alcohol plus carboxylic acid with an acid catalyst is an ester. Right. Naming this. You're looking for the longest chain. 1, 2, 3, 1, 2, well that doesn't, 1, 2, 3. Okay, whatever way I try and do it, it's got a longest chain of 3, so it's going to have a prop. It's propanol, but there are different. Could it be propan 1-ol, propan 2-ol? Well, you start numbering with the end of the chain nearest the functional group, but this isn't the end of a chain, so whichever of the other carbons we start on, the OH group is on the second, so it's propan 2-ol, and regardless of which of those you do, there's a CH3 group on that same carbon, so that is 2-methyl propan 2-ol. Finally, they want the structure of the organic product E, so you start off, keep it absolutely consistent with your alcohol, and then it was with ethanoic acid. So to make our ester, we are going to take the hydrogen off from the alcohol, and we're going to form an ester link. Just getting this in would get you 1 mark. That's your ester link. And then it's ethanoic acid. People often at this point think they're home free and stick on an extra 2 carbons. Careful, there is 1 carbon there already to eth2 in total, so you're going to have your CH3. And done.